Welcome to a lesson with Dr. Powell. Let's take a look at how modular arithmetic can speed up certain calculations very nicely. And it all rests on the fact that when you use a bar, like you're taking z and you're partitioning it up by with respect to the multiples of a number, like let's suppose that we do multiples of 7 maybe, so that we have 7 different distinct subsets that we've partitioned z up into. So 0 more than a multiple 7, 1 more, 2 more, 3 more, 4 more, 5 more, or 6 more. And that partitions it up. There's 7 of them, 7 subsets making this up. Let's suppose that we want to compute something like something that may even seem grotesque at first. Let's do like 5 to the 11th power mod 7. So we could either write it this way. An equivalent way of writing that is 5 to the 11th mod 7. So if you don't want to use the bar, if you know what the context is, but if you want to emphasize the context, you can always write this. Okay, so now we're going to use a fact that this bar preserves 2 operations very nicely from z. It preserves addition and multiplication. Whew. So that means that we can actually write this as for instance, we could write this as 5, and we can take things in and out of the bar as much as we want. So we could write this as 5 squared, and then maybe raise that to the 5th power, and then times 5. Okay. And then we can kind of think about this a little bit. We can put this bar in. So we can have 5 bar times, and then we can even put the bar in there and raise that to the 5th power. So we can kind of move the bar in and out as much as we want of anything. That allows us to just compute this and simplify this. So we kind of want to put a smaller operation in here and then simplify it. So let's suppose we have 5 squared, which is 25, which is 4 more than a multiple of 7. So this simplifies to simply 4. That already looks a lot simpler. Then if we want, we could move this 5. We could move this 5 in if we wanted to, or we could simply move, or what we could do is we could think of this as 4 bar squared times 4 bar squared times 4 bar times 5 bar if we want. And if we want, we could put the 4 and the 5 together, make that 4 times 5 bar, and that's 20, which we know is 1 less than a multiple of 7. So if we want, we could even write -1. Sometimes that's 1 less than a multiple of 7. So that'll replace this part right here. Then we're left with 4 bar squared times 4 bar squared. So we could move the square on the inside of the bar if we wanted to, like that, and think, okay, that's just 16. Hey, 16 is 2 more than a multiple of 7. So 2, 2. Very nice. You can move the bar. In fact, you could just move the bar over everything if you wanted to and just say it's -4 bar, which will be the same as 3 bar. 4 less than a multiple of 7, we'll just think of 7. 7 itself is a multiple of 7. 4 less than it is 3. So we could just say it's 3 bar. So we've just reduced a high power of 5 in modular arithmetic using the idea that we can move the bar out of a multiplication and inside of a multiplication. Thanks for watching.